Okay, so what we're looking at today, and actually for the next couple of weeks, is we're going to be looking at compound angles. And today we're looking at boring holes at compound angles. For example, what we have here is this block, and the hole goes into the block right here, and it comes out here. As you can see, it's offset in two directions. If I can try to sketch this out. In fact, I'll pause. So on a block here, the hole might be started drilling in here and exit the block here. So the hole has to go in that direction. See, it's offset in both directions. If we put a shadow from the center of the hole here, its shadow on this side of the block would be right here. Center of this hole is here. We're offset by that much. If we look at the end here, that one's centered there, that one's centered here. We're offset by that much in that direction. So what we need to do when we have to do something like this is we have to take this block and put it on the table of the drill press. Pretend that looks like a drill press. What we have to do is we have to tilt the table at the appropriate angle so that the drill will go through this hole straight. And we also have to turn the block so that it's sitting on that table. If we look at this table from the top, so that block is sitting at on the table at the appropriate angle so that the hole now goes exactly side to side. Make sense? So we need to figure out two angles. We need to figure out an angle of rotation, which is this angle here. We're going to call that R. And an angle of tilt, which is this angle here, which we're going to call T. Now, the amount of rotation here, if I'm looking at this block, and actually let me draw this out a little bit differently. What I'm going to do now is I'm going to isolate my drawing to just the holes. So what that means here for this picture is that's a little off, but that's okay. We're going to take the center of the hole on top to be there, and the center of the hole on bottom to be here. So the hole runs corner to corner from that corner to that corner. The angle of, connect this across the bottom, the angle of rotation here is going to be this angle right there, angle R. Because if I set this on the table, this side here would be side to side, so I have to rotate it that far so that it is now, that line of action is now side to side on our table. The angle of tilt, well, this would be straight up and down. This would be aligned with the drill if we just set it on there flat. So the angle of tilt is going to be this angle right here, T. Now some of the problems we're going to do are going to ask us to find this angle down here, which we'll call angle A. So let's look at how do we find some of these dimensions. Well, it's actually not all that tough with the basic trig that we have. If we are given that this material is 1.25 inches thick, and the distance from here to here is, let's go 0.75 inches. Excuse me. And the distance from here to here is, we'll go 0.40 inches. I can now find these angles pretty quickly. I'll start out with this triangle right here. That's going to be a right angle there. This angle here is R. That's my rotation that I'm looking for. Excuse me. I know both of the legs of that triangle. This leg here is obviously what? 0.75. Good. This leg up here is not quite so obvious, but it is 0.40. So angle R is going to be the inverse tangent of what? Opposite over adjacent. What's the opposite side? The 0.4. The adjacent side is 0.75. So second tangent of 0.4 divided by 0.75 gives us 28.07 degrees. So that's my angle of rotation. That's how far I would have to rotate this thing off of sitting straight on the platform of the drill press.
You always use the inverse tangent?
Yes. When you have both legs, it's always going to be an inverse tangent. Now for the other part, for the angle of tilt, it's a little bit different. First thing I'm going to calculate is something called the length of cut. Length of cut is just the length from this corner down to that corner. It's how long this drill has to bore through this material. And to do that, we're going to use something called the three-dimensional Pythagorean theorem, where that length squared is equal to the x distance squared plus the y distance squared plus the z distance squared. Or the length is the square root of x squared plus y squared plus z squared. Probably a little bit more useful form of this. So that length becomes the square root of 0.75 squared plus 0.4 squared plus 1.25 squared. Those are just the three dimensions of that box there. So that gives me that my length of cut will be 1.512 inches. So that is how far it is from the entry point up here to the exit point down here. So that's how far this drill has to bore through the material. What that does now is it allows us to look at this triangle here. This is a right angle. This here is L. This is that 1.512 inches. We also know that this here is the thickness of the material. So this angle here, angle T, would be what? Well, what sides do I have? This is the hypotenuse, obviously. According to angle T, this would be the adjacent. So that's a cosine. So I'm actually using an inverse cosine of adjacent 1.25 over hypotenuse 1.512. So second cosine 1.25 divided by second answer 34.22 degrees. And of course, if that's 34.22 degrees, this is 55.78 degrees down here. Any questions? Let's do at least one more example of this. I just used, instead of putting in 1.512, I used what was in the calculator. So that might be the difference if you're getting 0.24. So let's do with a piece of material here that's 3/4 of an inch thick. A 1 inch offset in this direction. 1 1/4 inch offset in this direction. So once again, we have to draw this line across the bottom. This is angle R. So you guys tell me, where do I start here? I can find angle R by doing what? Oh, that squaring all of them will give me the length of cut. Angle R is going to be an inverse tangent. If I look at it, that highlighted triangle, here's angle R. This is the 1 inch here, and this is the 1.25 inches here. So R is the inverse tangent of 1 over 1.25. Which gives us, yep, 38.66. Good. So that's our rotation.
Why are we using inverse tangent instead of tangent?
Well, because we're looking for an angle. We use tangent if we have an angle and we're looking for a side. But if we have the sides and we're looking for one of the angles, we have to use an inverse tangent.
Isn't that kind of the same truth on all of them?
On all of them.
Use the inverse, you always look
Yep.
for the angle.
If you're looking for an angle, you always have to use an inverse trig. Yep. Next, we're going to find that length of cut, which will be what? Yep, start squaring them all. Square root of 1.25 squared plus 1 squared plus 0.75 squared. Oops, that's not what I wanted. That sounds about right. Yeah, my calculator here isn't working real well. Here, let me try that one more time. 0.576 sounds about right. There we go. 1.77 or 1.768 is what I'm getting.
Would you have to square that 1 too, or no?
Well, 1 squared is 1.
Oh, yeah, I get it.
Yeah. So 1.768 inches is our length of cut. Now that we have that, I'm not looking at this triangle anymore. I want to look at this triangle here, which we're looking at it from kind of a skewed angle there, but this here, the hypotenuse is the 1.768 inches. That's our length of cut. Do we know any of the other sides? Yeah, we know this here. The material thickness is 0.75. So now I can find this angle T if I wanted to, which is going to be what? Perfect. Inverse cosine, because I'm looking for an angle, I use an inverse function. And this is the adjacent side and the hypotenuse, so we know it has to be inverse cosine. So inverse cosine of 0.75 over 1.768. $65.90 degrees. So that means this down here, if I was looking for that angle, would have to be 24.10 degrees. Any questions? Let's see what I do. It is 64.89. Why did I write down 65? 64.90. Some days the little hamster just refuses to climb onto the wheel. So this is 64 and this is 25.10. Thank you. Any other questions? Well, I think with that, you guys are ready to try some of these on your own. I'm going to give you a new packet. In this new packet, it's going to be page 392, 1 through 6.